In this video we will continue to learn quantum numbers. The magnetic quantum number, denoted by the symbol m, describes spatial orientation of an electron within an atom. Unlike the principal quantum number n, which describes the energy level, and the azimuthal quantum number L, which describes the shape of the orbital, the magnetic quantum number specifically relates to the orientation of the electron's orbital in space. It can take on integer values ranging from L to plus L, where L is the azimuthal quantum number. For first orbit, the value of both azimuthal quantum number and magnetic quantum number is 0. When L equals 1, the magnetic quantum number has three values: m equals -1, m equals 0 and m equals +1. When L equals 2, m equals -2, m equals -1, m equals 0, m equals +1 and m equals +2. Similarly, when L equals 3, m equals -3, m equals -2, m equals -1, m equals 0, m equals +1, m equals +2 and m equals +3. In simpler terms, the magnetic quantum number indicates the number of orbitals within a subshell and their spatial orientation in relation to the three axes in space, x, y, and z. Each subshell can contain one or more orbitals, and the magnetic quantum number helps differentiate these orbitals within a subshell. When the azimuthal quantum number equals 0, the magnetic quantum number, m, is also 0. It describes the s orbital, the simplest type of orbital in an atom. The s orbital is spherical in shape and has no orientation preference in space. When the magnetic quantum number corresponds to azimuthal quantum number's value of 1, it typically describes the orientation of the p orbitals within an atom. The p orbitals are dumbbell-shaped and oriented along the three perpendicular axes, x, y, and z, in space. For the p orbitals, there are three values of magnetic quantum number. m equals -1 corresponds to the px orbital. m equals 0 corresponds to py orbital and m equals +1 corresponds to pz orbital. L equals 2 represents the d orbitals. For the d orbitals, there are 5 values of magnetic quantum number. These correspond to the 5 d orbitals: dxy, dyz, dxz, dx²y² and dz². L equals 3 represents the f orbitals. There are 7 f orbitals. They have a very complex shape. The spin quantum number is used to describe the state of an electron in an atom. Unlike the other three quantum numbers, principal, azimuthal, and magnetic, the spin quantum number describes the intrinsic angular momentum or spin of the electron. The spin quantum number is crucial in understanding the behavior of electrons in atoms, particularly in the context of electron configurations, magnetic properties, and the Pauli exclusion principle. The Pauli exclusion principle states that no two electrons in an atom can have the same set of quantum numbers, including their spin quantum numbers. As a result, each orbital in an atom can accommodate a maximum of 2 electrons with opposite spin states.